Welcome, everybody. Thanks for coming to my talk. I'll be describing the next major Lucene and Solr release, which will be 8.0. Agenda is fairly simple. I'm going to talk about cadence of recent releases. And in a bit of a bait and switch, we're going to be talking most of the talk about 7.x releases, not the 8.0 release. We have not reached the 8.0 release. Recent movement on the development list suggests we have another month or two before that'll happen. So I'll talk about the 8.0 release, what's planned for it so far, and some issues post 8.0 in the 8.x release line. This chart shows the number of weeks between minor releases, and it's fairly consistent. I don't show earlier release lines, but it's been the case since 4.x release, 5.x, 6.x, 7.x, that the average interval between minor releases is about 10 weeks. So every 2.5 months, there's no new release, give or take. These are the topics I'm going to be discussing for 7.x. It's 15, a lot to get through, but we'll be fine. First topic, metrics. This is, in 7.x, a continuation of work that was begun in 6.x, principally to support autoscaling. In 7.0, aggregated metrics began to be collected in the overseer. If you want to use JMX, instead of configuring it in Solr config.xml, you have to configure it in Solr.xml under metrics reporter with a Solr JMX reporter. 7.1 added a Prometheus metrics exporter contrib, which can be used from Grafana. And 7.4 added an admin metrics history API, which supports aggregation of basic long-term key metrics. This is several resolutions of fixed width windows, and the example that I show there from the reference guide is a 4-hour window at 1 second resolution for the OS system load average. Unfortunately, this capability hasn't been added to the admin UI yet, although the API supports both text and image output in the form of graph. If you're interested in contributing to that, there's the issue, Solr 12.426, to add that capability to the admin UI. And the biggest topic for 7.x is autoscaling. 7.0 added a preferences and policy DSL for flexible replica placement. And I give an example of each of the two here. The first line there for minimizing cores and maximizing free disk is used when performing autoscaling operations to sort the nodes so that the system knows which one to choose. The second line there is a policy rule, and it says on any node for each shard in a collection, there can't be more than one replica, so that less than 2 means that. So a node can host either 0 or 1 replicas when this policy rule is in effect. 7.0 also introduced a diagnostics API, which can return nodes sorted according to the preferences. So if, using the example of the preferences there to minimize cores and maximize free disk, the first node would be the one with the fewest cores. If there were nodes that have the same number of cores, then they would be sorted according to the ones with the most free disk first as a tiebreaker. The diagnostics API also lists policy violations. So for each of the rules you've defined in your policy, it will tell you which ones are currently not being met, and that's termed a violation. In 7.1, the auto-add replicas functionality was ported to the autoscaling framework, and triggers and listeners were added, support to add, remove, suspend, and resume them. The first triggers were to add or for the events of added and lost nodes. And actions associated with triggers were introduced to compute a plan and execute it. Also in 7.1, an auto-scaling history API was introduced that allows you to see past cluster events and actions that were taken. In 7.2, a search rate trigger was added so that you can, for example, if search rate goes above a certain threshold, trigger some action, for example, add more replicas. An auto-scaling suggestions API was added that will look at your cluster, your preferences and policy, and give suggestions for how to resolve violations that are found. I'll show a little bit more about that on the next screen. And a utilize node collections API command was added so that if, for example, you add a new node, you can tell the system to go do the right thing according to the policy rules that I've set up. Continuing on with auto-scaling topic in 7.x, in 7.3, a simulation framework was added that we've been using to tell us about bottlenecks in the system. The simulation mocks many components of Solr and is intended to allow us to flush out problems with auto-scaling. A trigger for a threshold of arbitrary metrics was added, as well as a trigger for a fixed schedule. And admin UI to display and execute suggestions was added. So this is from a picture from the ref guide that shows it shows the rules that were violated, and there are suggested actions that you could take by just clicking on this button. Hovering over it tells you what it would do. Essentially, so although it appears to be the case that the reason for each of these 4 violations is the same, that is, so this rule says that for the getting started collection, there can be no replicas on nodes that have less than 500 megabytes of free disk. So as I said, although these appear to be the same, it's actually the case that these are different nodes on which this is occurring. And so the action likely, let's see, this is for moving a replica to a different node. So this suggestions API invoked through the admin UI will allow you to see what's wrong and take action from the admin UI. Continuing on with auto-scaling, a periodic housekeeping task was added in 7.4. Presently, it will clean up inactive shards that are left over from split shard operations. But the thought is that other activities will be added later. An index size trigger was added based upon document count or size in bytes, so you can take action if, for example, your index size grows too large to, for example, split shard. In 7.5, several new features were added to make the policy rules more flexible. In the replica attribute, the capability of selecting all of the replicas and saying that they should be targeted at a particular set of nodes, for example, was added. The ability to distribute replicas equally for a given collection or for each shard of a collection was added, as well as the ability to, at runtime, determine the number of replicas that a rule should apply to by specifying a percentage or range or a floating point, which effectively is a fairly tight range from the floor to the ceiling of the specified floating point. Similarly, for the cores attribute, and if you're not familiar with the way auto-scaling policy rules work, cores are simply cores in the system regardless of the collection to which they belong, as opposed to replicas which are associated with a collection. And the same improvements were added with the exception of the hash all keyword. So the ability to distribute cores equally across the selected nodes, percentage, range, and floating point values were added. The free disk policy attribute, which is used to select nodes for a policy to operate on, added the ability to specify percentage instead of absolute size. And a test was added to the testing framework using the autoscaling simulation framework that regularly tests scaling up to 1 billion docs. And Andrzej Białecki, who wrote the autoscaling simulation framework, has used it to manually test up to a trillion documents, updating, adding documents continuously and splitting as it goes, splitting shards and performing other operations. So we hope to continue to test the system and find problems and get it working better. Next topic for 7.x, cross-data center replication. The ability to sync bidirectionally on CDCR clusters was added. So not much changed in the image there in the reference guide, which is where this is taken from, with the exception of the arrows that I've circled there. It's just possible to say which cluster will be the one that you send updates to without having to reconfigure. So this is not active-active. Rather, you choose which of the two will be active at any given time. Next topic for 7.x is called time-routed aliases. There was a talk earlier at the conference about this topic, so I'm gonna describe the feature quickly, but not going to go into too much detail. This is a specialization of Solr's collection aliases feature, which is possible to set up so that you alias to more than one collection at a time. This supports time series data, for example, logs or sensor data, that sort of thing, and is intended to address the issue that if you continuously index into a collection, it can grow unbounded and become less and less performant. The time-routed aliases allows for a series of collections to be created, each one of which then can, the performance of which can be managed by adding replicas or changing the number of shards that you want to use. You use this thing by using the create alias collection command and specifying a start date, an interval over which a collection will take updates, and a retention policy, such that you can optionally have collections for older data be automatically removed. As you send in updates, if there is no collection for the timestamp on the update that you're sending in, a new collection, or potentially multiple collections, will be created to host the data that you're sending in. And as I said, the system can optionally be set up to automatically delete old collections. When you send in updates, the alias and update request processor associated with this functionality will route updates based upon the timestamp to the appropriate collection. Search occurs against all aliased collections, and there's a pending optimization to minimize the queried collections. If, for example, you know that there's a fairly tight range over which you want to query, then instead of querying against all collections, then it should be able to decide which collections to query against. 7.5 added the capability to preemptively create the next collection when updates are near the latest collection's end date, instead of waiting for the case that you get an update that refers to a collection that doesn't exist yet. 7.0 introduced new replica types. In addition to the already existing near real-time replica type, indicated here with NRT, the T-log and poll replica types were added. And these differ in the ways that I indicate there with the columns. NRT, the standard and the default still, replica type, indexes locally, supports soft commits and real-time get, that is the near real-time functionality. It does not pull segments from the leader, instead writes to a local transaction log and can become leader, and of course all these types are queryable. T-log replicas don't index locally unless they become leader, and don't support near real-time functionality. So there is a delay because segments are going to be pulled on some regular interval from the leader. However, T-log replicas write to a local transaction log and can become a shard leader. When a T-log replica becomes a leader, you can see that the row there for T-log leader looks identical to that for NRT. That's because it behaves exactly as an NRT replica type. Pull replicas perform a smaller subset of activities that the T-log replica does. They don't write to a local transaction log. The only way they get updates are via segments pulled from the leader. They can't become a shard leader, and so it's not possible to have a shard that consists only of pull replicas. You have to have at least one T-log replica mixed in with a shard. It's not recommended to mix NRT replica types with any of the other ones, so you want to either have all NRT or all T-log, or a mix of T-log and pull replicas. You can see from this chart that indexing locally and supporting NRT functionality, the checkboxes are the same. That's because in order to be able to support NRT functionality, you have to have a local index. Similarly, the columns for writing to a transaction log and the ability to become a shard leader are tied together. I mean, that having a local transaction log is what allows a replica to become a shard leader. In 7.4, a query parameter was introduced to prioritize replicas by type, so that you could, in this example here, use shards.preference to say that when you're querying, you want queries to prefer pull replica types and then fall back to T-log if no pull replica types are available. Next topic for 7.x is streaming expressions. I'm not going to go into what streaming expressions are. They are a multitude. Some use cases for this parallel computation function suite are MapReduce aggregations, parallel SQL, pub/sub messaging, graph traversal, machine learning, statistical programming. Each release in the 7.x line has added many new functions, and in 7.5, the ref guide added a math expressions user guide. Next topic for 7.x is the JSON facet API. In 7.0, terms facets added the optional ability to refine the facets. Previously, they were potentially inexact. In 7.4, a new relatedness aggregate function was added to support the so-called semantic knowledge graph functionality, which finds ad hoc relationships by scoring documents relative to foreground and background document sets. In 7.5, heat map facet support was added to the JSON facet API. It already was in classic faceting. Next topic, 7.x, config sets and schema. 7.0 introduced a default config set so that when you, for example, using bin Solr, create a new collection and don't specify a config set, a copy of the default config set will be made. Also in 7.0, in data-driven schema, AutoGuess text fields are now indexed in 2 ways instead of just one. They're tokenized for search, but also as strings for sorting and faceting. So you get 2 separate fields for each, copy fielded from the tokenized one to the string field. And the string field is truncated at 256 characters. Also in 7.0, it's possible now to turn off the data-driven schema functionality. So if you start out with a default config set, for example, which has data-driven functionality turned on, and you decide that you don't want to allow that any longer, you can just send in an API command. There's an example there that you just set a user property using the config API, update.autocreate field set to false. In 7.5, it's possible to disable config set upload, and there's an example of the sysprop you can give, config set.upload.enabled set to false when you start up a node. Next topic for 7.x, text analysis and machine learning. In 7.1, there was introduced a Bengali normalizer and stemmer. In 7.2, a shortcoming, well, not shortcoming, a limitation, I should say, of Zookeeper, which is that it, by default, can't host files that are larger than 1 megabyte in size, is problematic for storage of machine learned models, which can be much larger than that. And a workaround was added in 7.2 to allow for learning to rank models to be stored off of Zookeeper. In 7.3, an open NLP integration was added that allows for tokenization, part-of-speech tagging, phrase chunking, lemmatization, both with a machine learned model and with a set list of lemmas, named entity recognition, and language detection. In 7.4, a protected term filter was added that extends or generalizes, I should say, the idea of keyword capabilities. That, for example, stemmers can be told to leave certain terms alone. Unfortunately, this capability has to be supported on a filter-by-filter basis, and there are several filters that don't support it. This protected term filter factory allows you to extend that capability to arbitrary filters. Also in 7.4, a tagger request handler, also commonly known as Solr text tagger, was added. This can be used as a component and a named entity recognition system. It supports very fast tagging of free text. In 7.5, a Korean morphological text analyzer, a module called Nori, was added. And it actually was added to Lucene in 7.4, but the Solr configurations added examples to the config sets, to the schema, the underscore text, underscore KO dynamic fields that you see there. In 7.5, also a phrases identification component was added that identifies and scores candidate query phrases based upon index statistics. Finally, in 7.5, the Apache UEMA integration was removed. It had not been updated in quite a long time. Next topic for 7.x, collections API. 7.3 added collection level properties which are similar to the way cluster properties are supported. 7.4 added cluster-wide defaults for num shards, NRT replicas, tlog replicas, and pull replicas. These are options to collection creation. So rather than having to specify those for every collection that gets created, it's possible to set defaults. This is usable, for example, with the time-rounded aliases, such that when you auto-create collections, you don't have to specify those defaults for the collection creation. In 7.5, the capability to co-locate replicas of 2 or more collections was added, such that the auto-scaling will, when collections are moved, they will be moved, or replicas rather of collections are moved. They'll be moved in tandem. You just add the with collection parameter to the create and modify collection commands. This is usable, for example, with multiple collection join commands, which have this particular requirement that replicas are co-located for the collections involved. Finally, for 7.5 in Collections API, a new split method was added to the split shard command. The split method is called link, and it is 3 to 5 times faster than the original rewrite method, with the caveat that this slows down replication because instead of performing a merge to remove existing deleted documents, the entire index is sent. It just marks some subset of the documents as deleted. As a result, because hard links are not going to survive traveling to other nodes, when you send a split shard to another node, it'll increase disk usage because you have to host, until a merge occurs anyway, you have to host all of the documents from the parent shard. Next topic for 7.x, queries. A JSON query DSL was added, and there's an example here taken from the ref guide that shows and sort of easy to understand unpacking of the URL-based syntax that up to now Solr has had. Continuing with the queries topic at 7.x. In 7.2, a new synonym query style field type option was added. So synonyms functionality can be used to host relations between terms other than synonymy. When these overlapping terms are produced, you could use that capability to refer to more general and more specific terms in the same. So I give an example here for bird and robin. Robin being a more specific or hyponym of a more specific word, or hyponym of bird, which is the hypernym here. If you index these synonyms both at index time and at query time, before synonym query was introduced, I forget, sometime in 6.x, this would produce a Boolean query, and as a result, because of the way the more specific term is scored, you would see higher scored results when you used the synonyms at query time, such that you get better results for documents that referred to robin as opposed to bird. But when a synonym query was introduced, that broke that capability essentially. So this is a fix that Doug Turnbull produced, and he has a couple of blogs where he describes this. If you specify as same term, this preserves the behavior that's current now, the default. Synonym query is produced at query time for, if for example you query for robin, you will get both bird and robin overlapping terms. But you could also choose as distinct terms to get back the old behavior of bird or robin, or produce a dismax so that the term that's the most specific will be chosen for the query. Next, in 7.4, the JSON query DSL added the ability to tag queries or filters. There's an example there for hash color filt tagging the color blue query, which is equivalent to the local param there. So I'm glad Eric Erickson's here. He worked tirelessly on a problem of large index segment merging. So Eric, let me know if I get this description or the solution wrong. But essentially, overly large segments can be produced as a result of force merge or optimize that stop becoming eligible for merging because merges only select segments that are below a certain size. And as a result, if you continue deleting, they can accumulate a much larger than 50% percentage of deleted documents, and this results in wasted space and skewed index stats. In 7.5, tiered merge policy now respects the max segment size MB when you're executing optimize and expunge deletes. And the reclaimed deletes weight has been replaced with a new delete percentage allowed setting to control how aggressively deletes should be reclaimed. So it's now possible for really large segments that accumulate too many deletes to perform singleton merges that reduce the size of those segments. Did I miss anything or get anything wrong, Eric?
No, that's beautiful.
Awesome. Next topic, replication, recovery, and rolling upgrades. In 7.3, Kao Mandat, a colleague of mine, added a new implementation of the leader-initiated recovery algorithm, and the previous one is deprecated and replaced. As a result of this, in order to be able to perform a rolling upgrade to Solr 8, you have to be on Solr 7.3 or higher. In 7.4, I should have mentioned that DOT has a talk on that in the conference. I'm not sure if that's happened yet. So if you're interested in that topic, I'd look that up. In 7.4, the index fetcher skips fetching identical files, so it doesn't have to pull over information that's already got, making and speeding up replication as a result. Also in 7.4, buffer date updates are written to a new separate transaction log, and the ability to replay them in parallel was added. This, next topic for 7.x, block join and nested documents. Filters and exclude tags, local params are added for parent and child query parsers. These are usable, for example, for multi-select faceting. And 7.5 added a work in progress improvement, I guess, is one way to describe it, to allow Solr to more faithfully represent deeply nested document relationships. Currently, the client is required to reconstruct relationships based upon a flattened list of child docs that Solr returns. So this functionality is not fully completed, but it should be early in the 8.x release line, I think, based upon current cadence. Final topic for 7.x, miscellaneous. The ability to use an atomic update that adds a value to a multi-valued field has a new command that allows you to only add a new value to a multi-valued field if it doesn't already exist. A sort of deduplication functionality. 7.4, a new update request processor was added that allows the system to ignore large documents. So for example, you're finding that really large documents are screwing up your system. You can just disallow them, or I mean, you can accept them, but ignore them is what that update request processor does. An auto commit, also in 7.4, an auto hard commit setting was added to trigger a hard commit based upon the size of the transaction log. This is in addition to the maximum number of docs and max time thresholds that were already available. Finally, in 7.5, it's now possible to write custom cluster properties. Previously, there was a whitelist of allowed properties. Now, if you have a custom plugin, you can use cluster properties if you prepend this x.prefix. Next, we'll talk a little bit about 8.0. Autoscaling in 8.0, the suggestions API has a couple of new capabilities. First, options to rebalance are suggested even if there are no violations. You could use this if, for example, you know that the system is moving the direction that eventually will be violations, but it's not perfect. Also, the suggestions API added the suggestions for adding replica for when in the condition of a replica being lost. In 8.0, the index size trigger added the ability to limit the number of actions it will take to a maximum number of operations. So if the index size trigger triggers a whole sequence of split shards, for example, that could disrupt your cluster by forcing it to take on these long-term heavy-duty operations. And you can tell it to throttle those operations using this max ops limit. Finally, for 8.0, the autoscaling policy framework will be the default replica placement strategy. There actually are 3 now at this point. The original sort of round-robin placement strategy, the replica placement rules that existed prior to the autoscaling effort, and now the autoscaling policy framework. So going forward in 8.0, the autoscaling policy framework is the default. Next topic for 8.0, index upgrades. This one is not fun. At 7.0, Lucene indexes started recording the major Lucene version that created the index, and also the minimum Lucene version that contributed to segments. Based on that information, Lucene and so also Solr 8.0 will refuse to open indexes that were created with version n-2 or older, even if they have been merged into an n-1 index. So the trick of upgrading indexes to the previous major version, allowing you to cascade upgrades, will no longer work. Index upgrader will not upgrade starting at 8.0, 6.x or earlier indexes. So this means that reindexing, which frankly has always been the recommended practice, is going to be enforced. Let's see. 8.0, HTTP2. So in May 2018, Mark Miller introduced his Solar Cloud Starburst effort. I took this image from his GitHub repo in the background image. This effort is still a work in progress, has lots of cleanups and performance enhancements. And in July of this year, Kamandot took up the HTTP2 aspects. He ran an indexing test with 33 million documents and found that it produced much less garbage on replicas and quite a bit less on leaders, had more than 50% higher indexing throughput and much lower CPU usage on replicas. This hasn't been merged yet into 8.0, but it's blocking the 8.0 release and pending a release of Jetty, which includes Spinego HTTP2 implementation to support Kerberos. In 8.0, last topic, Lucene is starting to require that scores are non-negative. So function queries, will convert negative scores to 0. There's a to-do. Many deprecations have not been removed yet from 8.0, and the biggest of these, or the biggest impact, I would say, are try fields. And it's still up in the air whether or not that will actually occur. 2 things that are blocking that are a numeric equivalent to string field. There's a problem with point fields that they are not very efficient for doing single value lookups. And a numeric equivalent to string field would provide the ability to work around that. Also, there is no way at this point to automatically migrate schemas for .system collections. This is also called blob store, from schemas for pre-7.0, which include try fields to points. It is also the case that because of the way indexes are upgraded, that if you have a .system collection that survives multiple major releases, that it will stop being usable. So this is actually a blocker we really need to be able to do this, or else the system will just grind to a halt if you're using the blob store. Just a few more things about 8.x. The Lucene Solr minimum JDK. So there are lots of details about Oracle's release cadence post JDK 8. Oracle will stop supporting JDK 8 with updates in January, which is just a few months away. Both JDK 9 and 10 are end of life. Oracle won't provide free support anyway for them any longer. And it's likely that Lucene and Solr will require JDK 11 as the next minimum supported JDK, but there's no schedule to do that yet. The only known problem with JDK 9 Plus is that Solr's Hadoop-related functionality, for example, Kerberos, isn't really working. However, Uwe Schindler's Jenkins server, which regularly tests Lucene Solr on Oracle's 9, 10, 11, and 12 JDKs, sees quite a bit higher Solr test failure rate. So I encourage you all to, not in production, look at running JDK 11, because sometime in the fairly near future, that's going to be a minimum requirement for future releases. I don't think I have time to discuss this, but this is a history of an attempt to move Andrzej Białacki's Luke index toolkit, which isn't in Solr. It's a separate project, to move it from external to internal. There have been problems with licensing being incompatible with the Apache license, and there's been recent movement attempting to bring in a Java FX reimplementation that failed because of the way that that's been unbundled from the JDK in Java 11. The latest effort, Tomoko Uchida, has produced a swing version for Lucene Solr 7.5. So hopefully that'll become integrated into Lucene Solr shortly. These are things in Lucene that are not yet included in Solr. Index impacts, block max, WAND, and similarity cleanups allow some queries to be much faster, in some cases up to 10 times faster, when the number of hits is not required. Presently, Solr always tells you the number of hits. I'm being told that I have 0 time left, so I'm going to wrap this up. Feature field allows incorporation of static relevance signals. This also, for example, PageRank. It's also not in Solr. Soft deletes allows storing of document history, and RAM directory will be replaced by byte buffers directory. And we don't have time for questions, so sorry about that. Thank you.